In this video, I'm going to introduce how to interpret the vertical jump data or counter movement jump data. In part one, I'm going to cover some basics. When you look at the counter movement jump data, so x-axis is time, and the y-axis is not the force you actually exert against the floor. It is actually the reactive force. And the reason why you see positive values in, compared to here, 0, is because they are all reactive force that's coming back from the floor. So the y-axis, you're looking at the ground reaction force. There are some differences among typical ground reaction force patterns. So one of the reasons is, first, the protocols matters a lot. So if you let your participants swing their arms naturally, then you will see something like this figure. However, if you ask your participants to keep their hands on their hips, then the typical patterns will be different. Okay, there are also some individual differences. I want to introduce a third factor, but before that, I'm gonna go what the counter movement jump should look like. Start from standing still on the force plate, and then you get down as quickly as possible and jump as high as possible, right? So that's the counter movement jump or vertical jump. So the third factor is if your participants actually didn't do any of this, for example, didn't actually quite go down or didn't jump as high as they could, then you would not see these typical patterns. You will still some see individual differences. However, the typical patterns should look like this on the blue line. The red line you see is the velocity curve of the center of mass. Before we begin the actual interpretation of the data, one more thing I want to go over is that what you are looking at is not the resultant vector. When you do a vertical jump, ideally speaking, you want to exert force perfectly in vertical or perpendicular force to the floor. However, some force are leaking to the other force. Of course, I'm exaggerating, but the resultant force is is actually not the perfect. So there are horizontal component and there are vertical component, and therefore you have resultant force. What we are dealing with is not the resultant force. We are ignoring other forces or the resultant force. We are just looking at the vertical force. Okay, given these understandings, I'm going to start with some basic information. In part two, I'm going to break down into different pieces, different segments and phases of vertical jump. What you're looking at is the typical ground reaction force of the raw data. So when you look at the raw data, you see the value actually begins not from 0. It's actually already starting from the positive value where participants standing on the force plate, not moving yet, but you already see the positive value. So this is because you are already exerting force due to the gravity and your body weight, right? So body weight is mass times acceleration, right? Or gravity in this case. Therefore, you see the positive deflection even before the beginning of the movement. So that's one important point. And the next, so this is the starting point where the participants begin the downward movement. So this is the initiation of the movement. This is the takeoff moment. After the participants actually jumped, what happens is the force plate data will hit 0, right? Because he should be in the air. Therefore, there's nothing on the force plate. So this is what's called the flight phase, when the body is in the air. But as he goes down, the tips of his toes will touch the floor and you begin the landing, right? So this is the moment of landing. And typically, After the landing, you hit the very high spike. So this is the peak landing force. From the moment your toes from the moment your toes touch the force plate until you absorb force and then get back up and then you standing still on the force plate, all this phase is the landing phase. From here to here. One of the typical analysis we do is the force absorption. If you want to measure the force absorption, one of the indication is impulse. Impulse is by definition force times the time difference. So therefore, if you actually calculate the area under the curve, you can actually understand force absorption because by definition, it is the product of the force in time. I'm going to stop here and we're going to break down into more detail about the vertical jump in part two.